All right, all right. I'm gonna see how terrible my audio sounds and how terrible my background looks real quick. Where did Firefox go? There it is. Okay. Oh, it's working. All right, all right. Oh, the audio isn't bad. How terrible my audio sounds and how terrible my background looks real quick. Where did Firefox go? There it is. Okay. Here, let me mute myself. As people come in, great, we'll hang out. What we're going to be doing today, guys, is I've been working on a multiplayer online kind of server client setup. And the reason I'm doing that right now is I'm just trying to create a online like game engine that I can reuse to create different types of online games without having to set up the infrastructure for the server client connection, lag compensation, all that crap every single time. I see we got some people in the chat. I'm gonna start just by kind of like reviewing what I did with my server last time because it's been like a week and my brain forgets. But really what we were doing is instead of just having like some like obscure ass classes everywhere and some spaghetti code, I cleaned up my server so that it's actually had some structure to it. And so I'm still learning how to check like the chat and stuff, guys. If I ignore you, I apologize. Just maybe spam the chat and I'll see it better. I've always wanted to be a cool guy that says, hey chat, what's up? But I don't think that's gonna be me, but we'll keep trying. Anyway, what's up, Ellie? I got my dog underneath me, so I gotta be very careful not to move because she's sleeping. And yeah, so let me go ahead and close that out. I'm gonna go ahead and share my screen here. I'll just go ahead and create a new scene, screen, share, and then we'll go from there. Boom. Add source, add audio input capture, Lyra. You guys should be able to hear me still, I think, hopefully. Oh, fuck, okay. Add existing, Lyra. Okay, that works. And then, what was the other thing? It's v4l2, got it. Add source, video capture v4l2. Add existing v4l2, okay. Oh, wow, I got a big head. Okay, so we got my fat head back on the screen. That's good to know. Let's shrink my head up a little bit. Dun, 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 dun. Hopefully you guys can still hear me, otherwise it's a pretty boring stream. And then I'm gonna add one more source here, which is my screen capture. Okay, and then I'm gonna do that on my actual screen here. And I think I have to send this to back. Probably should have fixed this before I set up, guys, sorry. Learn how to stream, bad at it. Thank you for staying here and being my virtual friends. Perfect. Okay, so with that being said, hopefully nobody I know is watching this. But let's see, does the stream switch over now? Or do I need to like set this? As you duplicate order, save scene, screenshot, show menu, transition. Okay. Preview screen share. Oh, and then program scene. So how do I cut? Transition to, oh, it did it. Okay. And then it should be switched over. I'm just double checking in the stream and then we're good to go, guys. So I appreciate your patience here. I don't know how long this stream is gonna be today because my brain is fried. I've been working on a lot of like AI automations for my full-time job, which is an advertising agency. So we'll see how long my brain lasts. We're in, we're rolling, let's get it going. So, what we're looking at here is, let me actually just kind of like exit out of this. I edit my code in Vim. I'll just delete my changes, who cares? You all like a crazy person. But basically what we have going so far, just to review, is I've set up like a basic client server architecture, right? So inside of my setup here, I have 3 folders, client, server, and shared. Inside of the server folder, that's got like the latest, most up-to-date code where we have our networking separated out from our server. We have our protobuf messages, which is like how we efficiently send messages over the wire as opposed to using something like JSON, which is a little bit heavier. We have our player manager pie, which is about to be deprecated. We have our server pie, which is just literally a wrapper. Like, it's so freaking tiny. It used to be 500 lines of code. After my refactor, it's, 39. So it's a lot cleaner to read. And the way I got that to work is I moved everything over to use the entity component system. I had a hard time getting through it. I had to watch a bunch of YouTube videos. I need to credit the people whose YouTube videos I watched because they were really, really good and finally helped me understand it. But really the biggest thing that helped me to understand it was actually just trying to implement it, bashing my head against the wall, and cheating a little bit by asking Claude. So just to be 100% transparent there. Anyway, you can see I've moved everything into this like systems folder, right? So we have our input system, we have our movement intent system, we have our movement system, we have our disconnect system, we have our broadcast system. And that's literally the main loops that we're kind of running to manage input from players, because all of the actual physics and calculations are done on the server. We have an authoritative server that defines what's true and what's not. The only thing the player does from the client side is they send the actual input commands they want to run. The player validates they can, and then it actually runs them. The server validates they can, and then it actually runs them. From here, we could see in the beginning, just got through Genesis not too long ago, but in the beginning, there was 39 lines of code. Last scene buffer, we'll talk about what that is in a bit. Server tick, we'll talk about that. We establish our world, which is actually the container that holds all of our components associated with their entities, or I guess their entities are associated with the components that they have. We have the player manager, which I'm going to be getting rid of because it's very, very like sparse right now, and I can replace it by moving some more things into the actual entity component system. We have our input system that we set up, our movement intent system, and all this is it's really, really simple. So the input system, and actually let me just pull up like Excalidraw because that'll make it really easy to understand. I need to get a cool mustache like Prime again, and then more people will watch my stream. I think that's the key. So I'm going to shave my ugly beard. We're going to do mustache. But basically, with the actual system itself, I'm just going to do, is it still live here? Localhost 3100. I was running my own Excalidraw server now. I'm going to have to log in. Excalidraw.com. Do this over here so people don't see my, oh, wait, it is up, cool. Okay, so basically what we're doing, cool, is, and I still have my Cloud Code cheats up. There we go. Let me close this out. With the movement system, and I should have done this like side by side actually with my code. Cool. We have our input system, and right, so every like 1/20th of a second we're trying to receive this. The first thing that runs is the disconnect system. The disconnect system is checking. Each player entity has a component, I forget what the component's called, vSplit, split, dot, component or shared. Let's go up. We're in it. Shared. So each player entity has an associated. How was I doing math in here? That's my vector2 class. That's just like a helper class that I use. It has associated with it a connection component. And that connection component holds the UDP address of the client or the player, the last seen in milliseconds, I believe, and then the session token, which is like when the player actually sends their packets. We're not just letting them send their player ID and trusting that that's their ID. When they connect, there's actually a TCP handshake that goes on where the client connects, it asks for the player session token. The player session token is returned to the player or the client, and the client sends that with every single request, so that way we can actually authenticate that the packet we're getting is from the player that's trying to send it, as opposed to, let's say, I now want to be player ID 1, I change my player ID to 1, and then send it over in a player ID 1, right? That wouldn't make a lot of sense. That wouldn't be very secure. But the last seen is important because that connection component is used by the disconnect system, right? And so that's the first part of the loop that runs. And let me full screen this again. Split. Systems, or server systems disconnect system. And so what it's doing is it's really, really, really simple, right? We're getting every single entity with a connection component because the only people who have connection components are players. For each connection component, we get the entity ID, which is the key of this JSON object or this dictionary, if we want to be Pythonic about it. And then the connection itself. And the connection, I showed you guys what that was, right? It is shared components. And I'll probably separate these out as we go. But the connection component that we're pulling has last seen, UDP address, and session token. And so before we do any sort of calculations, we want to make sure that the player didn't idle out. And so the last seen is updated. I'll show you guys that here in a second, but if it's not, right, and it's more, the last seen of that specific connection is greater than our last seen buffer, which is 5 seconds, it kicks the player automatically and then just sends a packet to them, letting them know, hey, you've been disconnected. In most cases, this happens when they actually close out the game, right? It's not gonna happen while they're live, but it could, right? So that's the first part of the loop that runs in the disconnect system. In the input system, that's where things actually get interesting, right? Because we're actually taking input. And so let me just open that system up. Server, systems, and I separate the server systems from the client systems which I'm currently building because the client isn't doing any sort of movement or physics or anything. It's literally just sending input from the player to the server and having the server process that. But let's do the input system. And you can see here what the input system does is really simple. It's going to, in its update loop, which we run inside of the full game loop, we took our game loop from hundreds of lines of code to 1, 2, 3, 4, 5, 6, and then a blank line 7 if you want it, just by using the entity component system. And it's making it so much easier to expand upon this game. Last thing I need to do is clean up client today and make it like this, because you'll see my client in a second. It's freaking ugly. And we'll go from there. So getting back into this, right, it's going to pull all entities with position and input. And then basically on that set, or it's going to pull all entities that have a position and all entities that have an input. And then basically it's going to filter by just entities that have both a position and input. Because if a client has a position but not an input, there's no point in doing it an iteration, right? We're just going to waste compute doing that additional iteration when we don't need to. And so we're basically just doing that there. From here, right, we're pulling the input component, and then we're pulling the actual action itself. And the actions are structured as you can see here above, right? Our input component contains an input command, which can currently be none, move, or attack, I believe, and attack isn't even implemented. Actually, let's say the input command should be up here. Data class component, maybe not. It's probably defined in our proto buff, if I had to guess. Input command. Yeah, it is. So we're importing it from our proto buff. Cool. Anyway. And then it has an optional dx and dy, which is direction x and direction y. We do not allow the player to tell us at which speed they're moving, anything like that. We allow them to give us direction and we normalize it. And that's it. So with that being said, hopefully we normalize it. Actually, I got to check that. Do we normalize it? Oh shit, we don't. I think we just trust the player on that. So they could set in 1-on-1. Anyway, I think the movement intent processes it. We'll check it out. Anyway, so see, it's been a week since I checked this out. For entity ID, position, entities, keys, what we're doing is we're then going to match the action. If it's none, we just pass, right? Maybe I should even, I'll think about that later. We're trying to get to the client refactor. Input command move, right? If it's a move, we create a movement intent and then add that to our world with the entity ID of the player that we're processing. And then if it's attack, it passes for right now too. And then we drop that input component because otherwise, if not, it'll literally just have the same input. Let's say I'm holding down D to move right. It'll keep that same D input component until I do the next input, which we don't want to happen, right? We want, once the player releases D and stops sending that packet, we no longer want them to move, otherwise that would feel weird. So that's the input, input system. It creates the movement intent. The reason I do that is because as we add AI logic, the AI logic instead of the input system, the AI logic system, I haven't come up with a name for it yet, is going to create that movement intent instead of the input system, right? So the players add inputs to the entity component system through input. The AI or the NPCs are going to determine their movement intents using the AI logic system. So it kind of decouples input from movement. So that's why I did it that way, if you guys are curious. Let's pop over here to the next system. So movement, server systems, movement intent system, boom. And then we'll get to the movement system, and then lastly the broadcast system, because this is literally the entire client server architecture right now on the server side. From here, right, we have the shared components that we're importing, which are going to be velocity. I can remove component. I can remove input component too, because previously the movement intent system. Wait, why the fuck is that not there? Oops, probably shouldn't curse on the stream. But anyway, let's dive into the movement intent system. We set our movement speed here. This is in the future going to be changed to be held in something called a stats component, which will hold the player's stats, movement speed, health, etc. So that way, instead of it being set hard here, like each player can have their own stats that we can then store when they log in, log out, and that can be persistent across sessions. Now, in update, right, we're taking any position entities and any movement intent entities, and anybody who has both a movement intent and a position, we're going to process. If not, right, if they just have position, again, we don't want to waste compute power on that. I'm wasting memory. You could argue that. I definitely am, but I'll figure out a better way to do that in the future, because I'm not fantastic with proto buffs right now. Like, I'm still learning them. It was something I learned specifically for this project because I found them interesting. For entity ID, we're basically, again, like I just said, but it's taking that movement intent, right? And then what it's going to do is it does apply velocity. It takes the movement intent, x, times the self.movement speed, right? And then it takes the movement intent y, which is the direction, really, times the self.movement speed as well. So it looks like I do need to actually do the normalization on the server side, because it looks like it's being done on the client side right now. I could be wrong. We'll double check that. But anyway, world add component basically adds that velocity to, and velocity components are up here. They're very simple components. It's literally just a vector2 component, right? And our vector2 component is up here. The reason I have a base vector2 component is so that I don't have to redefine these dunder methods for add and multiply and divide every single time. It literally just inherits and normalizes, as you can see here. Oh, I guess we do normalize on this side. I must have missed it. Anyway, positions of vector2 as well, right? So that way they're all able to interact easily, right? They're all vector2s, and this will also make it easier to move to 3D as we do vector3s, because we'll just have a base vector3 class that we can inherit from for position 3D, for velocity 3D, etc. Anyway, so it adds that velocity, and then again, we drop the movement intent, because otherwise we would have the same issue with input, right? It would just continue to process that movement intent over and over and over again, even if the player's not still not trying to move in that direction. Popping back over here, server systems, movement system. We're getting there, guys. Thank you for sticking with me. Oops, wrong one. System.py. Okay, cool. So with our movement system, we're setting a few things. This needs to be changed, right? Currently, I'm bounding the player to 800 pixels wide and 600 pixels high. Not the right way to do it, right? As I add in like tile maps and that sort of thing, the player can see they're actually moving. And I actually set up a collision system, which is what I'm going to do next after refactoring the client. Then I'm going to remove all this crap. Is movement valid is just a quick check on the bounding boxes. It's going to get more sophisticated as we go along. We're actually going to be checking for collisions. I'm going to be watching a ton of YouTube videos on how collision systems work, because I've typically just relied on Godot for that. And then in the update loop, right, we're looking for any entities that have both a position and a velocity, right? If they don't have velocity, again, no point in wasting that compute. From there, if the movement is valid, right, so we first check if the movement is valid, right? We do position equals position plus velocity. If not, we do nothing, and then we just drop the velocity. So that's how that works. I just realized. Drop velocity, yeah. So we're putting the class type that we want to drop or the component type that we want to drop. So that's why I just use the actual class. And then world.add component, we add the new position to the actual world class. So that's how the system works. And then obviously once the server does all that compute, we need to tell the players that happens. So that's what the broadcast system is for. Oops, meant to go to the broadcast system. Right, so we're popping into here, broadcast system def init. All it's doing is we're literally taking the world, so our world class. We are taking the position entities, the connection entities, so we're finding players, I believe, here. We're going to be then assembling a world update packet, which I can dive into what that looks like here. I'll just go right over this. It's under E shared network messages proto. Our world update packet literally just contains a server tick and then also a players list, right? And so it's literally just holding this player state, which gives us player ID, which is irrelevant now. I'll be changing that soon to entity ID, I believe. We'll see. I could be wrong. The world update, though, holds all the players and then the server tick, and that's all it does right now. This I'm going to be changing to be one of, so that way it can hold, or I'll just kind of like abstract away player state to be like entity state. So that way we can do multiple different types like items, NPCs, etc. But again, I want to refactor the client first, and then we'll go from there. But all we're doing is we're basically building that world update packet. We are then setting the server tick to the managed server tick of the broadcast system, right? The broadcast system manages that tick. I know you shouldn't hold data inside of a system. I'm still learning this, so I need to figure out how to do it a different way. Or this could be completely right. I'm still, again, very unclear on the entity component system. I think this is right, so if you guys know better, let me know. But anyway, we got this rocking and rolling here. Assemble packets, send, world update, network message, PB2, yep. Tick for entity ID in position entities, keys, yeah. So we're basically taking all the entities with both connection and a position that tells us it's a player, right? And then we're basically creating a player state for that player, right? So take the entity ID, right, from this here. We're setting the player state.x to the position entities, entity ID x, player state y to the y, and then we append that player state to the world update, right? So that's adding to this list here. Once we do that, we copy the server packet from world updates. So basically this server packet we created up here, right? That server packet is supposed to hold one of either a UDP handshake, we could talk about that in a bit, a world update message, or a server kick, right? And so we're setting its world update message. We're copying it from the world update proto buffer that we created up here. Again, don't know if that's the correct terminology, but anyway. We're creating the packet to send, so we're serializing that to a string so it can be sent over the wire. And then for each connected entity, we are then sending that packet with the entire world update every tick, which is, I still need to do like a low water test on this. So we'll see how it goes. With that being said, you can see there's absolutely no sort of like lag compensation, interpolation, extrapolation, anything like that right now. That'll happen as we go along. But again, I want to refactor the client right now, and then we can easily add those systems later on. Because once we have the entity component system set up on both sides, it's very easy to add, because I'm literally going to be taking the same components from the client and the server, right? They share these components. So I can literally take the components from the server, and then I just have to make sure that the client reflects what was sent by the server, like the full world update. As it gets bigger, right, we won't want to send every connected player to every connected player, especially when they're on different maps, right? They're far enough away from each other where it wouldn't matter what the other player is doing, etc. And I'm not trying to have a huge freaking server bill to start out, at least. Yeah, so that's it. That's kind of how the server system works right now. The client is what we're going to have some trouble with. Before we dive into that, I'm going to go ahead and just show you guys how this actually freaking works. So I was doing some refactoring the other night, and I don't even know if I cleaned up before I was done, but we will see. So I'm gonna run my server, and you can see it has two threads. It's running the TCP thread and the UDP thread, and then it's running the main game loop as well in the main thread of this program. The client, cool. I can put my name in. Oh crap, I forgot to update that. Okay, I might need to get checkout, get stash, so I can come back to that. Cool. And then let me try running that again. Okay, cool. So you can see here, we have our one player. That's kind of boring, but you can see after 5 seconds of not moving, I don't get disconnected. That's because the client sends what's called a heartbeat packet every second, I think. So that way it doesn't get disconnected. But I'm gonna go down here and I'm gonna pop open another client. George 2. We're not sending names yet either, so this name is kind of useless. But you can see I'm up here. There's no way to tell which player is which right now either, outside of moving. But you can see, like, as I move around, I can see out there, there's no collisions here right now. It's literally just two white balls moving around the map, but they're communicating from the client to the server and back, which I think is cool. And that's the functionality I'm going for right now. I'm probably gonna keep this pretty ugly. I'm thinking at some point in the future, I'll have a competition for like creating graphics, pay people, the winners of the contest, etc., whatever it is, because I'm not a good graphic designer or a pixel artist, and I don't want to be. I like to create systems like this. But anyway, I will be making like a weird little like stick swords out of shapes. We got all those circles right now. It kind of looks like a player head, right? Can you guys imagine that? Anyway, so that's what the current setup looks like. Now, with that being said, I am out of water and my throat is drying the heck out. So we're going to pause the stream for like 2 minutes. Let's find some no copyright sounds because that's where we're going to be jamming. Hope you guys like no copyright sounds. Otherwise, this is going to be brutal. No copyright sounds. Pop over here.
Saw you in a field of ice and snow, holding out your hand for me. scared to see you, always knew it in my bones that something here was bound to take me home. You said you don't know me well, but I'm your angel in white. I'll be close if you come, I'll be just behind you. You're not on the list, but I can get you inside. Use your mind, listen to my voice.
One, two, three. Okay. Testing, testing. Testing, testing. Damn it. Okay. Testing, testing. 1, 2, 3. Yes. Okay, cool. 1, 2, 3. Okay. We're back. Okay. Okay. Testing, testing. Testing, testing. Damn it. Okay. Testing, testing. 1, 2, 3. Yes. Yeah. Okay, cool. We're at 1, 2, 3. Okay, got it. So we're rocking and rolling. We got our client server. You kind of saw that ran. This is the server, right? It's just taking the commands in. And again, if I kind of like just remove that removal of the input, for example, just to show you guys like why I remove things in the input system. Like let's say that I just never popped this input command. I'll just kind of show you what that does to the client itself. So let's do that. George. Right, so I'm gonna hit the right arrow key once. I put my hands up. You can see he just continues to move until I hit the next command, and then it moves that way, which could be really fun for an online snake game now that I think about it. Should I make online snake to start? That would be like the easiest freaking thing to make. I might make online snake, but then I have to create a lobby system, which would be kind of fun too, because then I could just do like fun, quick lobby games instead of an MMO, which I'm just not freaking prepared for right now. Okay, we might be doing that, guys. Anyway, but you guys could see like if I don't remove the input command, it's only stopping here because it's reached the bounds of the screen. So that's 800 pixels, 600 down, right? So anyway, cool. So let's pop back in here. Let's remove this and just rerun to make sure that it's working like it should be. So that way I don't go crazy, change some code, and then think it's the code. Whoops. Oh, I might just need to kill that. Nope, it's good. Just need a second to spin down. Make sure my audio is still working. Cool. So it's pop. Yeah, that's cool. Yeah, but you can see here, like when I let go now, it stops moving. But maybe we'll do snake. Maybe we'll do snake. Who knows? Let's rock and roll here, though. And you can see like the player session tokens generated here. So that way I can authenticate myself with the actual server to say, hey, I am the player that I say I am. Anyway. Let's get that rock and rolling. Let's move into the server now. Right, so we understand how, or the client, we understand how the server works. It's basically set up where we have our loop, right, our game loop. First, it's connecting, right? It uses TCP to do the initial connection so that we know for a fact that it'll work, right? That the server will actually receive our message and the client will receive it back. And then for the UDP handshake to connect to the UDP server that handles the game tick, right? We use that player session token on the initial connection, which you could see somewhere. Where am I even spawning that anymore? I don't freaking remember. Anyway, somewhere I'm listening for a new player connection. It could be in the input system, now that I think about it. No. Broadcast system, disconnect system. Oh, start networking, here it is. It's running in those threads. Right, so that's where client networking comes in, or server networking. Server networking is we have two threads. We have the TCP thread, which we start up, and we have the UDP thread, which we start up. And those are those messages you're seeing at the server start. Setting up our IP, our UDP server port, our TCP server port, and our buffer size. Talk about what create player connection response is. But inside of our network messages, so like our protocol, our proto buffers, shared networking messages, proto, we have our UDP handshake, and we also have, we should have player connection response. So player connection request sends a username. That's why I asked for a username at the beginning. It's completely useless right now. I'll show you on the client side, but in the server, it sends this player connection response, which has a Boolean of connection accepted. If it's accepted, it's true. If it's not accepted, it's false. The player ID, which again, we don't need anymore, and then the player session token that's generated. And so what's happening in here is in the TCP server loop, we're setting up our server socket, we're binding it, we're listening, because that's what you need to do, right? With TCP socket. Or with UDP, you just kind of bind, if I remember correctly. And then we just have a literal loop that processes one connection request at a time. I could set this up to be multiplexing, right? We could use, I think it's poll. For multiplexing, so that way it'll just listen to a bunch of different file descriptors. It won't be blocking. No, it's a different one. I don't quite remember, but I'll find it later. We're not going to do it right now, so it doesn't matter. Anyway, we accept a new connection, right? We receive the buffer size, and then what we try to do is we try to parse the player connection request, because that's the only sort of request the TCP server should be receiving. And I should probably have some try-catch logic here for this in case it fails. But we try to parse connection request right up here from the string that we got. It'll say, hey, this is what we received, and then what it'll do is it'll create the player. So the player manager players, it's basically just grabbing the length of that to determine the player ID, right? Pretty freaking easy. The username is from the player connection request. The player connection response we then create via this method that we have up here. So it's literally taking in the player ID. It is creating the connection response, right? So this protocol buffer. The player connection response, or the message, It sets the connection accepted to true, which I could have done within here, right, during the actual construction of that message. We set the player ID, and then we set the secrets token URL safe for this specific player connection. Now, what I just realized is how the heck do we then store this? Player connection response, it returns the player connection response. So player manager, add player, player connection response, and then it sends a message. I think I should do a send to instead of a send all here now that I think about it. But player connection response, it then sends it to the clients. Serializes the string before sending it over the wire. Player manager, add player. I assume it grabs the player session token here. It does. And so basically, self.players, we set a lock around this dictionary. It sets the player ID as the key, and then the value is the player ID, the username, the token, and then the entity ID, which is initially set to -1. This can then be set later using an update player, because we take the player ID, the key, and the value, and that's how we actually add the entity ID to the player object itself. So that's it. You can see, guys can see it's really thin. It used to be a couple hundred lines of code too before we did ECS. So that's it, right? That's how the server works. Now on to our beautiful, beautiful client. What we're gonna do is I'm gonna open this time. I'm gonna open my client.py. I also want to open vsplit client networking, because I've been working on that. Whoops. And then what I'm trying to do right now is I'm trying to basically rip the networking logic out of the client, just like we did with the server. And then from there, what I'm going to do is I'm going to start building the actual systems for the client. And I need to figure out what those systems are. The way I can do that is I'm literally just going to take the current game loop. So we're going to have, where the heck is it? There. So like our current loop, this is our setup. We have like our render, which I don't know why I have that above this. We have our update function. I'm currently not using delta time at all because there's really nothing to use delta time for. But literally our game loop seems to be basically pulling the latest broadcast world and updating that. So that'll be a system itself. The handle player inputs, right? So we're handling the player inputs and then sending them to the server. And then if there's no player input, we're sending a heartbeat, right? And that's the entire game loop right now. Okay. So that should be pretty easy to extrapolate out, but we'll see. Or sorry, extract out. Okay, let's do it. Oh. So this is currently working, but we have some overlap. And this could definitely be cleaned up too. Okay. Matter of fact, let me extract these out. I know we're probably going to delete it, but just to get this crap out of the way for right now. E client player.py. Okay, e client world.py, I think. Let's see. We need the world update queue. And the queues are automatically protected. I don't even know if this should manage itself, but whatever. Queue. Current server tick. World should also, I guess, hold that self. Current server tick. That's a global. I'm gonna need to fix that too. That's gonna be a pain in the ass. Alright, well, we're just gonna mess with this for now. Global current server. Okay, we're gonna replace all the instances of that. So we're just gonna do, oops, percent. Oops. S world update queue. Do self dot update queue. GC. Yes. Oh, that was it. Probably could have just typed that out. That would have been easier. And then for current server tick, we're going to want to do the same thing. Probably shouldn't have done the first one. Now it does self. Okay. Server tech, and then that should fix it, let's hope. Incoming IDs, PID. Error is, we need to import player from client import player, import player. Should work. We're about to find out. Cool. It looks like that's fine. Understood. Okay. And then let me go ahead and then just import this. So from client, client.player, import player. And then from client.world, import world. This should work, so we're just going to test it. Server hasn't changed, so I'm going to leave that as is. Oops. I always mix up like my tmux and my vim movement commands. Oh, come on, dude. I think I have mouse enabled. Yeah, let's use that. Screw it. Don't judge me for using mouse and tmux. But, cool. Fingers crossed. It's broken. Oh. That's why. It's expecting world update queue, I think. Doesn't work anymore. Fuck, I broke it. Let's see, any more errors? Beautiful. Okay, we did break it. Thank gosh. Kicked from server because we didn't send the heartbeat. Oops, I wanted to see that error. That sucks. Okay. George. Okay. And then Q is not defined. Did you forget to import Q and world.py? I likely did. Where are we defining Q? Oh, there it is. We're catching that exception if it's empty. So from I'm just gonna steal it from over here. There it is. This is gonna bug me. Okay, cool. We should be good to go now. The spray and pray method is the way, guys. And the spray and pray method, as you just saw, works. Okay, cool. Our thingamajig's working now. Okay, cool. So we got that going. Cool. I need to remove this once I'm done debugging because it's just, there's that input output is just unnecessary. Or that output. Cool. So now we got these moved in their own class. We clean this up a bit more. Now we're down to 131 lines. I like that a lot more. We still need to move all of this crap over. I think this makes sense to keep in the game loop for now. And the current server tick, I don't know if we use it anywhere else. Tick. We don't, so that can get removed from here. I'm going to do client utils.py, and I'm literally just going to be a bum and just shove everything into here that we need as far as utilities go. Data class out from data classes, port data class, and I believe I can also get rid of this up here because I don't need it anymore. And do we not call player anywhere else? No, we don't. So we can get rid of that too. Cool. I do need to import that util though. So from client. Ow. Sorry guys, my back is messed up today. Utils import color. Just make sure that still runs. I don't need this anymore. Oh. I don't know why. Oh. Duh. Okay, let's see. Does this work? It does! Our ball still moves, and it is the color white. Cool. So we got that cleaned up. We got a few of this. These new lines out of here. Okay, let's see what we're down to. We're down to 112, guys. We're getting there. Let's see if we can get down to sub 40 like we had for server. We most likely should be able to. It's much smaller on the client side. There's a lot less going on. It's literally just showing pretty pictures and taking input. So there's no logic, no physics, no anything going on the client side. I will eventually add prediction to the client side, so that way we can compensate for any sort of latency. But yeah, for right now, no. So player ID, world update queue, if name equals main, UDP client socket, socket.socket, socket. Okay, so we're establishing the UDP client socket here in the UDP server address. We are initializing the connection using connection init. I believe that comes from the actual networking module. It does connection init. So let's see what that does. Sorry, that was loud, guys. She's still asleep. Cool, shouldn't hear that. Cool. So in the connection init, it's asking for the username. It is sending the player. It's creating the player connection request. So remember, guys, we have inside of shared, we have those protobufs that we're sharing. Freaking love protobufs, by the way. Now, never sending anything over the wire any other way now. No, for web applications. I'm still definitely using JSON. But anyway, network messages, proto, right? And then inside of here, we have player connection request, right? So that player connection request is composed of a variable player username, which is a string. I meant to do a vsplit there. Vsplit, e client, networking.py. Cool. And so that's what we're doing and creating there, right? We create that with the username that we just collected from input. I have it in Bash right now because I just don't care to create a text input setup or field within the Piglet application at the moment. We'll get to that. That'll be like pretty stuff. Right now I want to get functionality out of the door, and functionality that's actually sexy, not a text field. So then we set up the TCP client socket, grab the TCP, or set up the TCP server address, which is composed of the server IP and the port, so a string and an integer. We send the TCP connection request, right? It's a TCP client or socket connect with the TCP server address. So that's when our server accepts the connection, right? So if we go back over to server networking and we go to the TCP thread, we saw there was that exception state. Not exception, sorry, exception. Accept right here, right? That's what we're basically hitting when we say connect. If I still remember correctly. Connection request packet, player connection request serialize the string, right? So we are basically taking the player connection request, serializing it so we can send it over the wire, and then we're sending it. From there, we're going to wait till we receive data, right? Because we're not doing anything else until we receive a response back from the server. And that response is the player connection response with the player ID, the entity ID, let me see, split. So player ID, connection accepted, and player session token. Okay, so this is Boolean. So connection accepted, player ID, and then the player session token. No point in moving on, because if we don't have a player session token, we're not able to communicate with the server. It's just going to reject everything we send. Player connection response, right? It grabs that, right? Tries to basically parse the data that we got back from the TCP socket into a player connection response message type. I still need to look up the actual nomenclature for protobufs. I just dove into freaking using them. I was like, I don't give a shit what it's called. Receive connection response, which we'll see, right? That's the message we're seeing when we connect here. So receive connection response, connection accepted true, player ID 5, player session token. And it's counting up, right? This will change, right? I'm gonna give players like permanent IDs that they can use during connection, or use the player session token. I really can't like persist the player session token. I'm trying to figure out like how I'll do that for persistent storage, so when you log out, you don't restart the game every time. Unless it is one of those games where it's like a lobby-based game, like a Snake, right? But even then, maybe keeping like high score and that sort of stuff could be important and fun. Anyway, player connection response, we got the player ID and the player session token. I'm surprised this still works, player ID token. Anyway, where else did I set player ID? Might have just found a bug. Glad we read through this. Oh no, it returns it. Okay, so I did think ahead there. But we don't need that player ID and player session token above. Anyway, cool. And then it's establishing the connection with the UDP server. Basically what we're doing there is with the UDP server, we're doing a single request, and we're actually doing it, I think I set it up to do it multiple times if it fails now. I may not have done that. Yeah, max retries, because UDP packets aren't guaranteed to send or be received, right? And so we don't receive something back from the UDP client socket or UDP server socket, I guess, after 2 seconds. We're gonna retry it 5 times and then give up, right? And just have the player restart the game for now. But basically this handshake protocol is basically allowing the UDP server to associate the IP that we're coming from with the player session token, I believe. So we'll go back into that in a second. Right, we have the game packet, networking messages, PB2 game packet. Game packet, the reason it's game packet and not like handshake, UDP handshake, etc., is we do have a UDP handshake message type. But that UDP handshake message type, sorry, that's server. That's the acknowledgement. There's a UDP handshake. here it is, UDP handshake, is literally just the player session token, same with heartbeat, right? And then that allows us to more gracefully handle the packets coming in, right? Instead of having to have like listen for rather specific packet types, we can just listen for game packet, and then when we're processing it on the server side, we can just determine which type of packet it is, which you guys should have seen that, right, inside a UDP server loop. What's happening is when we receive a packet, it's basically we're saying which one of, right, payload in game packet, right? If it's a handshake, right, it's going to execute the UDP handshake logic where it is creating the player session token. Sorry, it's not. Oh, it's grabbing the player session token from the handshake message, right? It is getting the ID by player session token. That's from the player manager. If the player ID is not none, or is none, right, it'll just say player not found. Handshake failed. And then it sends that back. And then if it is, right, it's basically just sending success false in the handshake acknowledgement, right? So we can see handshake ACK here, success true or false. If that fails, then we know the UDP handshake failed and we need to redo that, right? And so the UDP client socket sends to the server, the UDP server. It tries, right, gets the data. And if it does, it breaks out of this while loop. And if it doesn't, it just tries again. No ACK received, retrying handshake. Once it receives something back, it's grabbing that server packet, and then the server packet, it's parsing it from the string, returning the player ID and the player session token. What I just realized is I need to check. Because I'm not doing anything here with this. Oh, I did have this set up, but it's just going to return here. Sorry. Anyway, server packet parks from string. If not success, it'll say UDP handshake failed and then raise an exception. Cool. So we got that rocking and rolling. We're looking good here. Yep. And then you can see, like, if we get input instead, right? The most intense piece of logic is this handshake here, right? And then input's really simple, right? It takes the player session token, it finds the player entity ID based on that from the player manager. From the world. Get entity ID by token. And then if the player entity ID is not none, it'll basically add that player connection component. It gets the player connection component. And then what we're doing there is we're updating that last scene, right? And so we were talking about the last scene, like the disconnect system in the server. What's happening there is if this doesn't happen either by a heartbeat or by a input event, that last scene will exceed the buffer, right? Because time dot monotonic now minus the last scene will be greater than 5. It then creates a player input component, right? Which is what we process inside of the input system. It adds that component to the world with the player entity ID. And then that's it, right? And then for the heartbeat, does kind of the same thing. It literally just adds that heartbeat component to the entity component system for that specific entity. So, with that being said, that's it. That's our entire system right now. We need to get into the input. We've refactored a lot of this. We've pulled player and world out of the main client. And then we've also pulled the color util out. So last thing really here is I'm going to clean up networking and then move on to the entity component system being fully set up for the client as well. Dang, I need to clean up this freaking networking too. Cool. Close this out. And then, okay, we're inside of networking here. Why do we still have a server IP over here is what I'm curious about. So enter UDP event loop, UDP client socket, set timeout none, okay. Networking threading, .thread, that's fine. So we're setting up the UDP client loop in here for some reason. I don't like that. Networking thread start, and then when is it sending those packets? Okay, it's sending them. That's the issue. So we're handling networking stuff directly here within the client right now. I think the best way to extrapolate that though will be to actually create the entity component system. Damn, I'm trying to think like what the container should be called. Like client world, local world. Yeah. Because what I want to do is I do want to move this into the UDP thread. Instead of processing every frame for Piglet, we're literally going to add the latest input into a input component inside of our entity component system on the client side. And then the UDP thread will handle popping from that. Maybe we can even do like a list of inputs. That wouldn't make sense. Yeah, so I think what we're going to do is I'm literally going to split it out. And the first thing I have to do is actually create the entities and the components. Okay. So let me kind of make a note of this here. Vim. Yeah, so I'm going to create, oops. Input component 4. Create input system and client in the main game loop when listening for input instead of processing directly in the game loop. Add an input component for the player entity. We won't have to loop here because it's only the player entity that we care about. I think that's going to be the best way to do it. So what's a fuck? Okay. Yeah, I think like the entities, we're also going to have things with positions and things with like some sort of display component, and then the display component will tell us to render. I'd like to store that in data somehow on the server, even as simple as just like a color and shape definition right now, and in the future move it to some sort of like sprite. It'd probably be easier to do a sprite though, because that's just one object type or class. Maybe we move to an image right now. Okay. Here we go. We're going to open gameart.org. Let's find top-down 2D sprite. Slime. Okay. Yeah, this might have to be my slime. That's even better. Oh no, freak, it's animated. Okay, well, I just got a virus, that's cool. Cool. Oh. Whatever, my art's terrible right now, it's better than mine, so. We're overcomplicating the shit out of this, George. What are you doing? Go back. Go back now. There we go. Okay. Create entity, add component. Okay, so we have our world, we have our client. Let's just start creating the systems, I guess. Oh, wait. Handle input keys, key state handler. Why wouldn't we just have the input system handle the key state handler? That would make a lot more sense. And then we can just, inside of this update, call the input handling system. Yes, okay. Okay, let's do that. Client, oops. I think I have to mkdir client systems. There we go. And then client systems input pi. Okay. And then I just want to compare it to server. No, I'm confusing myself. Well, I do when I do that. Systems input system. And then what are we taking from here? We're taking in the network messages input command. We're taking shared components, the shared system, and then the shared world. Sick. Oh yeah, because I can just inherit from our shared system. Split shared system.py. Yeah, it literally just requires it to have a update function that takes in a world parameter. Okay, I forgot all about this. Thank you, code, for reminding me what the heck I did. All right, so I'm gonna do split client systems input system.py. Right, and then from shared system import from shared from shared.world import world. And then what we want to do here for our input system is going to be a little bit weird, because the input command is going to be an output of this, as opposed to in the server, the input command is an input of the input system. Okay. Okay, we can do this. From server.network messages pb2 import input command. And then, see, I'm glad I streamed today, because otherwise I would have given up already. So class input system system def init self, and then we need key state handler, I think it was called. Key state handler. I do want to define the type of that. Oops. Come on. There we go. Piglet window key. Cool. I'm importing that. From piglet.window. And I do want to like decouple the actual like rendering library. Like I want people to be able to use Pygame with this too if they want. Piglet window import key. Cool. And then it's going to be a key. I'm going to just do key. Actually, no, because I'm going to need this for processing. Key. I forgot what it's called. Key state handler. Cool. It's actually not going to be correct. That's what it is, a freaking function. I need to figure out what this function returns. Key, key, instantiate the handler. Oh, okay. Duh, I should have given it away. Okay. Key state handler. And then we're going to do self key state. I'm just going to do keys because that was actually easier. Keys. Cool. So now we got that set up. I really like this like update contract too. Cool. And then from here, what we need to do is basically on every iteration, we want to, I don't know what window push handlers does, honestly. I just kind of like copied off Piglet's site, so I probably should learn Piglet a little bit more, but we're just gonna spray and pray right now. Best way to find out if it works is to run the code. Okay. And then we're handling the player inputs here. So basically what I want to do is I just want to literally rip this code. Yeah, it works. For now. Okay, and it's pissed at me now. That's fine. We're about to figure out why. So command equals none if keys, that's self.keys now. (13 to 45). 13 through 45 s keys. We're gonna replace that with self dot keys gc. What? Oh, there it is. Cool. So we're gonna say yes, 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 yes. Is that it? Cool. And then key imported. Network messages is not imported. I'm gonna just directly import whatever the hell I need. Input command. Cool. Let me do it the lazy way. Import server. Why am I doing it from server instead of shared though? We're doing client. No way that doesn't freaking work. There we go. We got it. Cool. Okay, so we got that. What's the issue here? It's gonna continue to yell at me, that's fine. Is not known, that's fine. Player session token is not defined. That is true. Dang. Self player. I definitely need to clean this up later, but I'm just going to do it this way for now. Okay. I think in the heartbeat it makes us set that too, right? No? Socket is not defined. Oh shit. We don't want it handling that. So that would be the server communication system. I don't freaking know. We're about to find out. Cool, yeah, because the input, we don't want it to... Shit. Well, input component out, just like I said, right? So here we want to basically create input component for server comms system send. Looks very confident right there. So because I control D that, I want to just comment that out for a sec. Okay, so from there we want to create that. The input component, do we have an input component? We don't. So boom. Let me go ahead over to here. I'm gonna do server, no. The player also doesn't know its own entity ID. Crap. Okay. That's okay. We're gonna figure it out. E. Here it is. Okay. Perfect. So we actually have exactly what we want. Does it start off as 0 and none? Yeah, it does. Cool. And then we don't want it to be none. We want it to be input command none, right? I is going to be, network messages pb2 dot input command none. Oh my gosh, it's gonna work. Command network messages pb2 input, and then we got that going. So it's gonna be equals network messages protobuf2 dot input component. It's going to be input command equals command dx equals dx dy equals dy. Cool, so we have the input component. Now we just need to add it to the entity component system with the entity ID. And literally, I'm just gonna set the player's entity ID to freaking 0. I think that's gonna break something. Create input component. Do we have access to the world? Import world self.world. World, okay. So then what we want to do is world dot add component. I definitely want to change this to entity ID so that syncs between the server and the client. Let me just make a note of this here real quick. Split will be fine. Nope, not what I meant to do. Split to do. Line with current server setup. Okay. Okay. So world add component, we need the entity ID, which is just going to be self player. Oh, it's not anywhere in here. What do we have? It's the input system. That's it. Okay, so we're literally just setting it to 0. That's fine. So world add component 0. Kind of makes sense to set the player to 0 because 1, the entity ID is never going to be 0. There is going to be an issue there with the player IDs because we're currently using that, but when it's entity ID, maybe it is 0. I don't freaking remember, but then I'll need to just set entity ID to start at 1. Okay, cool. And then we're going to add the input component. And then that server send system, whatever the frick we're going to call it, server comm system, is what will handle this input component. And that's where we're going to take this code and run that over there. Okay, cool. So now I'm going to do east client systems server comms system dot py server send server input system server input to server system put to server system. That's what I'm calling it. That's our name. We'll change it later. I don't have the brain power to think of names right now. Input to server system. The best system name ever created. Don't at me. Do people still say don't at me? I don't know. I might have just aged myself there. Okay, cool. YY. DD. Boom. Okay. So. Input system. Input the server system. We're going to have an init. What's going to go in that init? Don't know. Pass. We're going to have a world update system, right? I think it's just called update and then self, and it's required to have world, and then inside of here, pass. I don't know what it's going to do. It's going to do something. No, it's going to take the second half of this. So that'll go Shift I, Shift V. I don't know. Let me check something real quick. Oh, nice. Okay, so okay, so there's a lot of shit we're gonna have to clean up now. Input the server system. 38 lines of code in the input system now, guys. Refactored. Okay, so we got that. Thank God for Git, right? Because otherwise, if I had to revert this, not happening. I would just give up on the project. That's what I used to do before I learned about Git. Like when I was younger, when I was like 14, 15, making projects. I would just like, I didn't know Git existed, so I would like make changes to a code base and it would just be so freaking broken. I would just be like, all right, well, that was fun while I made that game, but we're done now. You know, it's game over. Anyway, it's kind of nice because sometimes you like actually rebuild it from scratch and it would turn out better, but whatever. Enter UDP loop. Handle player inputs goes here. Okay. Executes updates from server, world update from queue. Oh, okay. So that's already something that's running. I'm going to turn that into its own system now. Because we want to have like a server broadcast processing system. Or like process server. I'm going to prioritize world updates over player inputs right now, which may be stupid. I don't know. We'll figure that out. Okay, so everything is an error now. We've done great, guys. We've gone from doing good to errors. So that's where we're using it before. What I want to do is I want to do messages pb2 dot input command dot none. Cool. And then we just want to pop off get all entities with, I think. So it's world.get all entities with input component. Well, actually, no, we just want it for one specific entity because we're not processing it for anybody else except the player. So let me find that shared world. vsplit shared world. Okay, shared world. Get entity by token ID, get all entities with get component, and that allows us to specify entity ID and the component. Yep, that's it. World.get component. 0 is the entity ID, we know that, and then we want to do input component component from client.network messages pb2 import input component. Wait, no. From shared.components import input component. Right? Yeah. Oh no, I am. Alright, let's check over here. Input component is in components. Yeah, I fucked that up. Because we're not at the network level yet, so I don't know why I hallucinated that. We want this. We don't want from shared.components import input component. So you guys, this is what happens after you wake up, work all day, and then game program. Brain slog. So I appreciate your all's patience through this. Input command, I didn't even have to do input command because they're doing it straight from network, or straight from, yeah. Dude, I am hallucinating. Wait a freaking second. Okay, no, that should be good. Yeah, then we just don't need that. So, there. Thank God NeoVim tells me when I'm messing up. Except for this, because that's not right. So we got that. We got the input component. We added it to the world. That works. And then in the input to server system, we now have system and then shared components input component. And then I do, yeah, I'm gonna do that. Okay, come on. Okay, so we got that. We got the input component now. So we're going to grab the input component. We're gonna do player input component because it's the only one we're grabbing. Player input component equals that. And then if player input component dot command, and then this is also wrong because input command is, no, that is, okay, sorry. Okay, input the server system. So we have our player input component, if player, I'm shedding, it's that time of year, I'm shedding my winter coat. Player input, that's fine. Shin token. Oh, we do need this. Player input command equals player input component dot command, fixes that. YW P, oops, undo. And then packet, that's fine. Input UDP client socket, we need to set. Crap, I was gonna do that in the UDP loop. No, I think this works better. Okay, so UDP client socket send to packet to send. Or I could just queue it. Let's see what else is down here. It's basically the UDP client socket that we need. Okay. UDP client socket. It's going to be socket.socket and then UDP server address. Should I bother defining this? It's going to be string int. I feel like that's getting too aggressive with definitions, but whatever. Self dot UDP client socket equals UDP client socket and self dot UDP server address. Thank God that for this ergonomic keyboard equals UDP server address. So self UDP. Okay. So now the last thing we have to do. Why is this getting pissed? World is not defined. That's a fair reason to be pissed. From shared import world. I think, yeah. No. Come on. Stop. Come on, buddy. Why? From shared dot world import world. Get it rolling. %s UDP client socket place with self dot self p client socket gc no yes. All right, so it's 23 to 29. UDP server address place with self.udp server address. Done. Did I break it up here? No. Cool, I got the right line range. So we got that rocking and rolling. Honestly, that should be good to go now. So what I want to do is prior to entering update, we have to actually instantiate these system classes. So I'm going to do from client.systems.input system import input system from client.systems.input to server system to be renamed server system import input to server system. And then from here we want to basically at the top create these. I'll do that before we even get to creating the window. So we're going to do window or input is equal to, equal to put system, and then what goes in there? The keys. So we need to do it a little bit lower. Keys, and then I don't think we need player session token anymore. So let me bring this down here. Let's go here. Instantiate systems. And then I am going to remove player session token now. Actually, player session token. Okay, yeah, because it only shows up in those 3 places. So we don't need it. Okay, back over to our client, and then we're going to do the input to server system to be renamed. Input to server system, and it's going to take player session token UDP client socket, I think UDP address, I don't remember, or server address. I don't remember what order I put it in. Hopefully that's it. That looks like it's right. Okay, cool. Yeah, it is right. Cool. And then handle player inputs, which is down here. So we're going to do input system.update world. And then input, fudge. Because this world is different than our ECS world. Okay. Input to server system dot update world. Yeah, because this world is of a different world class. Because I have this world, and then I have the other world that I didn't import. Son of a butt. World. We're renaming it. From shared.world import world. Yeah, I need to clean that up a lot, but for now, what I want to do is I'm literally just going to replace anything that currently says world with client world. I'm gonna GC this just so I can make sure it all looks right. No, no, yes, no. Is that it? Cool. And then I'm gonna do %s world, and then we're gonna replace that with client world, GC, no, no, yes, yes, yes. No, no. Cool, that gives me an error now. That's what I want. And then inside of client world, client world, world.py, gg, call this I client. And that should fix that. Yeah. What's up, Ellie? How are you? How are you? Hello. Who's a good girl? Yeah. Oh, you can see her in the background there too. Yeah? What's up? What's up? I agree. I agree. I'm a very good programmer. All right, cool. Where were we, Ali? Where were we? I already gave you the D word. Well, dinner. Jesus, that's bad. Dinner. Can't give you that. I gave you treat. I took you for a WALK. So, I don't know what you want. How can I help you? Have I been streaming for too long? Let's see. It's only been 107 minutes. That's a pretty long time, isn't it? Give me till 120 minutes, and then we'll do the other WAOK, okay? Okay, good girl, good girl. All right, so, back in a world over here. What are you doing? You give me sass, huh? Some good sass, I might be convinced. Let me finish this. My brain's finally in like flow state-ish, okay? Okay. Wolf once for okay. I'll take that as a wolf. What, dude? You guys see that? You can't. She's just like staring at me. Let's see. What do you have to say to the people? Here's back. You're caught now. It's on camera. Pop this back up here. I know you can't see her. Oh, what? Dude, give me 12 minutes, okay? 12 minutes. I got you. Okay, so inside of this world, I'm gonna see how we declared it inside of, well, why is there an error here? Socket is not defined. Well, that would make sense because I didn't import socket. Why? server.py, and then where do we, okay, so we literally just instantiate an empty world. Cool. So world, let's do this up here. World equals world. what? What's up? Yeah? Oh. 11 minutes, okay? You're not very good at counting. It's only been 1 minute, 2 minutes. World. What? You guys see this? Yeah. Oh, now you're on camera. You're playing nice again. Oh, okay. All right, guys. Well, we got to call it a stream there. We haven't made it 2 hours, but I have a little lady to take care of, apparently. So this is goodbye for now. I'll come back. Maybe do another You guys see that dot? I just saw on the stream. Yeah. Oh, she gave up. Cool. Client world. Ellie, I see this through. Input system update. World. Okay, that should be good. I think we're good. I'm gonna try it. Clear. Crap. Key state handler. Piglet window key has no attribute key state handler. Did you mean? I did mean key state handler, not key stat handler. Okay, and that is in the init of the input system. Ellie, you don't know how close we are. Okay, try now. George. Oh, crap. Okay. That was a big change. Player input command is not networking. Input component object has no attribute command. What? Input command. Input command. So it's okay. And where was that happening? That's happening inside of the input to server system. Are very well named. Setup. And player input. Wait, this is the player input. So I need to fix that up. So E shared network messages. Player input. Player session token input command. Yeah, and I just call command there. Alright, let's just try rerunning it. George. Network messages PB2 is not defined inside of input to server system. I don't believe you. Ah, you're right. Okay, you win this round. Why? Okay, we're almost there, guys. To the finish line. George. Okay, we're seeing the ball populate now. We're getting closer. Okay, input component has no attribute command. What line is that? That's line 20. Input the server system. Okay. G. There it is. Boom. We extrapolated out the input system from the actual game loop. We did it. We done did it. Alrighty guys, that is an hour. No, that's 114 minutes in. So we're like an hour and 54 minutes in. We have reviewed the server system that we have set up, the entity component system, how that processes all the players' inputs and then broadcasts them back out. We reviewed how the client was set up. We then cleaned it up, right? And now we have it set up where the client, I think the code was 150, 139 something lines. We're now down to, maybe a bit more, 92 lines. So saved a good bit of room there, moved a lot of these systems out into their own system. I'm gonna come back next time. I wanna move the client world update. That's literally just it handling the broadcast from the server. I wanna move that into its own system as well so we can define that really easily. And then from there, single close, piglet collect. Yeah, I can't complain. So we're literally setting up all this stuff for piglet. And input system, yeah. Yeah, so I mean, we don't even need this because this is just BS anyway. I just did that to test piglet when I first set it up. See what else we got. Any other free new lines we can take out? There's one. Okay, let's go ahead and check this out. 84 lines, guys. Cut it almost in half. So looking all right there. Not fantastic. Nice, good. Add, git commit, SM refactored client to use ECS for input handling. Git status clear. We are good. Let me shut down this server too. And that's it for today. That's it for today, guys. Go ahead and call it a day there. Hope you guys enjoyed hanging out. Hopefully you learned something. Maybe next time you guys can teach me something. But other than that, I'll see you.